Hey there, all. Good to see you. A couple more types of concentration here. Today we're going to be looking at molality and a dilution calculation. Molality, lowercase letter m, possible units moles per kilograms. So keep those in mind as you move throughout the scenario here. Concentration value used to calculate boiling point elevation and melting point depression. So just a useful unit to pay attention to. Don't get confused. Molarity and molality are very different. Sound the same, but very different. So be very, very careful with that. First example problem here. What is the molality of a solution in which 15.6 grams of potassium chloride is dissolved in 1,500 grams of water? A couple things we need to pay attention to here. Our equation is moles of solute over kilograms of water, so make sure you get that solvent converted to kilograms, and you'll see the calculation up there on the screen to go from grams to moles. We pull the molar mass off the periodic table. That's our dimensional analysis. So biggest mistakes we see here, grams not be converted to kilograms for solvent, so be aware of that. Divide by 1,000. Next here, mole solute divided by kilograms of, sorry, that says solute on there. Make sure you cross that out. That's solvent. And top divided by bottom there. Make sure you round to significant figures. And try not to round in the middle. I took one more digit than I needed to with the 0.2092. So just be careful with that. But you don't want to round twice. I think I put a little note in parentheses there. But you can always pause this video, go back, watch it again if you need to. But this is your molality. There's two student examples for you to then work through. Okay, on to dilution then. You will have an activity with dilution, so dilution is very important. Use it all the time in our class when we're combining solutions and things. M1V1, molarity 1 volume 1 equals molarity 2 volume 2. So equation 1 is just to figure out if we add more water, how does that change? How does that change the concentration? The second equation, too, is if we take two different concentrated solutions and mix them together, what's the new concentration? So there's another example problem here. Please pause the video and work through the example problem if it's going too fast. Big thing here, since molarity is moles per liter, your volume must be in liters. So you'll see that the 200 milliliters was converted to 0.200 liters. But to get V2 by itself, which is our unknown, we divide by M2. Notice those cancel out. And we can go ahead and get our final answer there. Sig figs, two of them, two sig figs, digit term, exponent, and label. So don't forget those things. Please complete the assignment. If you have any specific questions, please reach out to your teacher.